Alright, so this is going to be our first day working with 6.3. So we're going to be going over graphing radical functions. Now, this is back to our transformations again. We've done this almost every unit. We're going to be looking at our parent functions for square roots and cubic root functions. We will only do this for up to a cubic root, so don't worry about anything after that. So, for our square roots, remember, with f of x equal to the square root of x, well, if I plug in a -4, that would technically be a positive or negative 2i. That's imaginary. We can't actually graph that on our regular xy axis. Same with this -1. That would be a positive or negative I. Now a 0, we'll just have a 0. With 1, when we plug into our calculators, we get a positive 1 out. And we plug it into our calculators with 4, we get a 2. Technically, when we do our square root, we get the positive or negative. But if I want it to actually be a function and pass my vertical line test, I can't use both the positive and negative. So we only use those positive values, which is why in your calculators, the positive is the only one that comes out. So our graph for a square root looks something like so. If we think about our domain for this one, well, if I go into negative numbers, I start getting imaginary numbers back out. I can't plot those. So starting at 0, I start to have points. So my domain, x needs to be greater than or equal to 0. For my range, well, if I let my range be in the negatives as well, I would technically have this over here, but I would no longer pass that vertical line test. So my range here is any y greater than or equal to 0. So if I look at my y-axis, well, my lowest point is here, that's at 0, and it could be any value above that. Now for our cubic root, at -8, well, we get a -2 back out. That's a real number. Remember, when it's an odd, we will always get a value back out of here. So when I plug -1 in, we get a -1, 0 will get us a 0, 1 now will get us the positive 1, and 8 gets us the positive 2. So if I cubed each of these, we would get back to that x value. So now if I try and plot these, this doesn't quite go out to 8, but 8 would be around here, and we would be down at -2. At -1, we're at -1, 0, 0, 1, 1, and then at 8, we would be at a positive 2. So our graph ends up having this kind of shape like this. Has a very steep increase in the curve. Now for this one, I was able to plug negative numbers in and get real values out. So our domain is all real numbers. And our range, I could go up and down to any value and still find a point on my graph, so our range is also all real numbers. Now down below is the chart for the rules of transformations. We filled this out once before, so what I want you guys to do is pause the video and try and fill these out on your own, and then I will fill these in for you to check your answers with. So go ahead and pause now. Okay, so when we are on the inside here, remember that is a horizontal change. So if I am on the inside and I add something, that's going to move my function to the left. Out there. When I subtract on the inside, it's going to move my function to the right. Never forget that your horizontal always is going to do the opposite of what you're expecting. So if I'm adding something, it shifts it to the left. Subtract, it shifts it to the right. That also affects things when we multiply. With horizontal, we are always changing x. So remember, our negatives, those are our reflections. But if I want to change my x values, so I have some random point here, and I want to switch it so I have a different x value now. You guys can't see this. So if I have this point and I want to change it, well, I would need to reflect over something that was vertical. So we reflect over the y-axis. So reflect over y. Now, when we're multiplying by a number greater than 1 on the inside of our function, that's actually a shrink for our horizontals. It does the opposite of what we expect. When it's a fraction between 0 and 1, well, that causes it to stretch. Now on the outside, that's our vertical change. So that changes y. So for these ones, they work pretty much how we expect them to. If I add, it's going to move me up. If I subtract, that'll move me down. When I have a negative, that's still a reflection. But this time, if I want to take that point and change its y value, I need to reflect over an x. So if I want this to be down here, I would be reflecting over that's something that is horizontal. So an x-axis. So reflection over x. When our numbers are greater than 1 here, these will be our stretches, and when it's a fraction between 0 and 1, those will be our shrinks. So double check you have these all in. Okay, so flip your pages over. We were on page 12. We're going to be on page 13 next. So this is page 13. Now we're going to be doing some example problems with this. It says to describe the transformations and graph each function, identify the domain and range of each function. So for this one, our transformation, well, on the inside of this function here, I see a 1/4. So it's underneath my radical. That means it's on the inside, so it's going to be a horizontal change. Now, it's being multiplied. So if we look at our chart and we say, okay, well, it's being multiplied, that's one of three things. It's either a reflection, a stretch, or a shrink. I can eliminate reflection because it's not negative. Now I'm just stuck with stretch or shrink. With our horizontals though, remember, we have to take the opposite. So really, this is something by a factor of 4. So that means it's going to be a stretch. That's why it does the opposite, because our factor is greater than 1, but what we see in here is less than 1. So when I see a fraction in here that's less than 1, it's going to be a stretch horizontally. Our factor is 4 because we take that reciprocal over here. Now, we've graphed our square root parent function before. It had the points 0, 0, 1, 1, 4, and 2. So take a second, graph that on your paper. If you need extra time, go ahead and pause. Now, if I'm doing a horizontal stretch by a factor of 4, if we think about a horizontal stretch, that means it's going to get longer. So I'm going to go ahead and make a little chart over here to help me find some values. And this is going to be our transformation, f of x. So if I plug in 0, well, we'll still get 0 back out. Now if I plug in 1 though, we have the square root of a 1/4. Well, a square root of a 1/4 is going to be a 1/2. If I plug 2 in, we won't get anything nice out. But next, if I plug 4 in, well, 4 times 1/4 is 1, and the square root of 1 is 1. So now what our graph looks like, I'll graph this one in orange. We have this point 0, 0 still. We have 1, 1/2, and we have 4, 1. So our graph has been stretched out this way. We pulled it out to the right. So this is our f of x, and in pencil we had our parent function. Now, if we think about our domain, we didn't shift it left and right at all. So our domain didn't change compared to our parent function. And we said the domain of our parent function was x greater than or equal to all zeros. Sorry, greater than or equal to 0. What that means is if I go to 0 on my x-axis, I'm like, okay, a point exists here, and values to the right of it exist, but to the left, there shouldn't be any points. Now for our range, f, well, if I look at my lowest point here on my y-axis, I see 0, 0. I can't go below to find any points. There's nothing down here. But if I go up, well, I could go up to 1 and over. There's a point there. I could go up as far as I wanted and still find points. So our range of s, well, y, greater than or equal to 0 still as well. If we look at b, our next transformation, it's a -3 on the outside. So we have two different transformations here because not only do we have that 3, but we also have that negative out in the front. So that negative, that's our first transformation here. That's a reflection. If it's on the outside, it's over x, because that's what helps us change our y values. Now that 3, that's going to be a vertical stretch by a factor of 3. So what we're going to do here is we're first going to graph that parent function. Remember, this is the one that had that curvy shape, had these points here, 0, 0, 1, 1, -1, -1. It also had the points 8 and 2, so it goes all the way out across my axis before I even get to my next point. It goes all the way out off my grid before I even get to my next point. So this is that parent function. Now, if I'm stretching it vertically, it's going to get a lot taller. So if I check some points on x and g of x, well, I could look at a -1. When I plug -1 in, my cubic root is -1, and then I'm multiplying by 3, that's negative, so our negatives will cancel, and -1 times 3 will get me a 3 back out. I plug 0 in, we'll get another 0 still. Plug 1 in, we'll get a -3 this time though, because the cubic root of x, if I plug 1 in, that's 1 times a -3, that will get me to a -3. Okay, so what we'll do next is we'll take those points and plot them to help us graph this. I'll do it in orange again so it's easier to see. So we have that point 0, 0 again. Well, -1 now is all the way up here at 3, and 1 is all the way down at -3. So, right now it looks like a straight line, but we know this is curved. If we think about if I plug 8 into here, that's a 2 that comes back out. Well, 2 times a -3 would get me to a -6. So down here, we would also have another point about here. So that'll help you guide where your graph is going if you need it. So this is our g of x. So then on this side, if you want to think about that again, our 8 would be way up here technically. Come over, it would be at that 6. So just to help you guide, you can kind of draw that point there, like, okay, I need to get past that point. Now our domain for this one, once again, I could plug any x value in and find something. So x for this one is all real numbers. Our range though, before it was only positive values, well this time I can go into the positives or down into the negatives, all real numbers again. So, there are 2 practice problems down below. I want you guys to pause now and try number 2. It's very similar to that first example I did, but it also has the negative on the inside now.